everyone. This is our first section, which is in chapter 11. 11.1 is all about sequences. And start from 11.2, we will learn series. So firstly, let's take a look. Definition of sequence. So a sequence is a list of numbers. Is a list of numbers. So I will give you some examples later. But right now, this is general definition, which is A1, A2, A3, and AN. Infinite series, so we have infinite terms. So this in a given order. Okay, this is the definition. And here, all the I, they are called terms. So it's like A1, A2, AN are called terms of the sequence. Okay, and here 1, 2, 2, 2, and they are called index. Okay, and now let's take a look at the example. So here I have 2, 4, 6, 8, and 10, and the general term AN is 2n. So let's see, this is a sequence. It's just a list of numbers, right? And now let's take a look at what is the terms. What's the other terms? A1 is 2, A2 is 4, and in general, what is AN, which is 2n? Actually, this is all the odd number. Let's see the notation. So there are several notations. The first one, so sometimes the sequence is given by just the formula of AN. For example, AN equals root n. So this sequence means what? 1, root 2, root 3, and root n, like that. Okay, and the second notation is called like this way, which is given by group of those numbers like this. And the third notation, AN equals this, n from 1 to infinity. So actually they all mean the same sequence. Okay, they all mean the same thing. And most of the time we just we use the first one a lot. But in the book, you could sometimes you also see the third one. Now let's take a look at the example. So in example 1, the formula of AN is given. So by using the formula of AN, we want to write out the sequence. So let's see. For a given formula, AN, which is this one, let's find the first several terms. A1, A2, A3, and A4. So this is pretty easy. For the sequence, is always n start from 1. Okay, the first term, so index, right? First term, second term, and the first term. So A1 equals what? That means n is 1. So we just plug into our formula AN. 1 minus 1 over 1 square is 0. And A2, 1 minus 2 over 2 square, which is negative 1/4. A3, which is 1 minus N3, 3 over 3 square, which is negative 2 over 9. And A4 is 1 over 4 over 4 square, right? Negative 3 over 16. So just plug in the formula. So it's pretty easy. And here you can try this problem. And AN is given by 2 plus negative 1 to the n. Same thing, find the first terms, 4 terms, A1, A2, A4. Okay, and please do the problem by yourself and check with my answer. And here I just give the answer. So when you watch my video, you should pause here and do the problem by yourself and check with my solution. Okay, next one, example 2. For the example 2, is the opposite way. Given the terms of a sequence, we want to find the general formula. So find a formula for the sequence like this: 3/5, -4/25, 5/125, and -6/625. Okay, so this is given sequence. We want to find the AN. Now, firstly, let's take a look at those numbers. And if we look at the denominator, we noticed there are 5, 25, 125, 625. Can you see what those numbers are? So it's like for the denominator, which is 5 to the power 1, and 5 to the power 2, 5 to the third power, 5 to the fourth power. Is that right? So for our general term, we can try to write down here. At the bottom, which is denominator, AN. So the first term is 5 to the first of 1 power 1, so to the nth term, 5 to the power n. And if we look at the top, numerator. So numerator, if n start from 1, so actually they are just like numbers. If we start from 1, 2, 3, 4, we can just write down n on top, right? But the numbers start from 3, so it's like 3, 4, 5, 6. So it should be n plus 2. Yeah, right? If you write down the general term for that one, it's n, but for this one, n plus 2. So we write down n plus 2. Now let's take a look at the sign. Okay, so we haven't treated with the sign. So it's positive, negative, positive, negative, right? So that means it's going to be -1 to some power. And the first one is positive. Okay, n start from 1. So if we put n here, so first term will be -1. So we cannot do that. So we can add 1, or you can do n minus 1. So they both are correct. Okay, so the general term is -1 to the n plus 1 and times n plus 2 over 5 to the n. Okay. Now you can try this one. 4, -1, 1/4, -1/16, 1/64. Let's take a look at this one. Okay, you can try. And for this one, you can start from the third term and find the general, and then can find the AN. Okay, the solution is, please work on this by yourself. Definitely, I have -1 to some power. The first one is positive, so I still do n plus 1. And then here I should do 4 to some power. The third one is the 1's power, so -2. So start from the third power. Third term is going to be 1/4. Numerator is always 1. And when you finish this one, please double check your answer. For example, if we plug in n equals 1, so what is A1? -1 to the power 2, 1/4 to the 1 minus 2, which is +1 times 1/4 to the -1, which is just 4. Right, same as our sequence A1. Okay, so now I'm going to give you several sequences, and let's see what's the difference between them. The first one, 1, 1/2, 1/3, 1/4, 1/n. Okay, so can you see what's the general? Actually, 1/n, right? Is given. Okay, the second, 0, 1/2 to 1/3, 3/4, 1 minus 1 over n. Okay. And the third one, √1, √2, root n. And the last one, 1, -1, 1, -1 is alternating. Okay, so let's see. For the first two sequences, you can see the last term approaches to which number? Approaches to 1 over n, the limit when n goes to infinity, approaches to 0, right? If we just look at an. So here I should say an approaches to 0. And if we look at the second sequence, an approaches to what? Approaches to 1. 1 minus 0, 1, right? The third one approaches to which one? Infinity, because n goes to infinity. And the last one, the limit, actually, we learned this in calculus 1, does not exist because there's no certain number can be the limit of this an, right? It's always changing, +1, -1. So you can see here for the full sequences, for the first two, an approaches to a certain number. So for those two kind of sequence, we call them converges. Okay. And then for the next two sequences, the an has no limit. In this case, we say those diverges. Okay, so second definition is the definition of converges or diverges of a given sequence. So let's, if we just look at the last term or general term, an, okay, the limit an equals to a number, we say exist. And then we say the sequence converges. Otherwise, we call that diverges, or we call that convergent. Okay, otherwise, we say the sequence diverges. All divergent. That's the definition. Okay, next is kind of limit rule. Is given by the theorem. Okay, theorem 1. So we have two sequences, and both are convergent sequence. So let's see, let an, bn. Okay, sequence. They are sequence, right? B sequences of real numbers. That means all the terms are real numbers. And the limit exists if the limit for an is capital A and the limit of bn is capital B, then we have those following conclusion. Okay, the first one. Limit of an plus bn. Actually, this is the limit law. Okay, we learned this in calculus 1. So here we just do the quick review. So this equals capital A plus capital B. And the second one, this we also call the sum rule. And the second one is called the difference rule. So you can guess actually an minus bn, right? Which is a minus b. And the next one is called the constant multiple rule. That means if we use constant times an, and which is k times a, we can take the constant out of the limit sign. And the number 4, which is quotient, goes to infinity, an over bn, which is a over b. Okay, and we also have a product rule. Number 5, an times bn, which is just a times b. So we skip the proof. We learned this before. So here we just need to know how to use the rules to find the limit of a given sequence. So let's see. The first one, n goes to infinity, -1 over n. So let's take a look at what's the limit. Okay, so actually you can tell this directly, right? The limit actually is 0. But I'm going to show you just use the constant multiple rule, which treat this as -1 times limit of 1 over n. But you don't have to do this step in the future. It's just -1 times 0, which is 0. You can also treat this as -1 over infinity, right? So limit is 0. The next one, okay. There are two ways to do this problem. Okay, the first way, I'm going to show you two methods. The first one, you can simplify this. Use n minus 1 divided by n. We can simplify this into 1 minus 1 over n. And this is 1 minus limit of 1 over n. So which is 1 minus 0, which is 1. Right? This is method 1. The other method, you can do this way. In calculus 1, okay, I think you learned 1 minus 1, we both use numerator and denominator both divide by n. So let's see. N goes to infinity. So 1 minus 1 over n on the top and 1 at the bottom. So the answer is also 1. You can use any method. Okay. We just want to find the limit. Number 3. N goes to infinity. 4 minus 7 n to the 6. Here n to the 6 plus 3. Okay, so this is same as what we learned before, like if we have x to the 6, x to the 6, it's also is similar to the previous problem number 2. So we divide by both, n to the 6, n to the 6, and simplify. Let's see, here become 4 over n to the 6 minus 7 for the numerator, right? Denominator 1 plus 3 over n to the 6. And because n goes to infinity, this term goes to 0, this term goes to 0, and be careful, it's -7 over 1, so the final answer is -7. Okay, this is how we do this kind of problem. I'm going to just give you several problems here. The first one. If you can tell the answer, you can also write down the answer directly. You don't have to show me the detail here. It's pretty easy. Three problems. Okay. Take a look at those problems. The first limit equals to, you can divide both by n cubed, right? But the answer is 2. This one, which is -1. Okay. How about the last one? The last one, this term goes to 1, but we have negative, positive, so the limit does not exist. Okay, there's no limit. Or if this is our an, the sequence diverges. Next, let's take a look at example 4. But before that, we are going to do one theorem. It's called sandwich theorem. Or same as before, we learned the squeeze theorem for the limit. Same thing, they are the same thing. It's called sandwich theorem for sequence. Okay, so here we have 3 sequences, AN, BN, and CN. real numbers, and if Bn is in the middle of An and Cn, okay, greater than An, less than Cn, for On beyond some index n. That means Bn doesn't have to be for all the n. It's just for some certain, like when n goes to large, it's in between An and Cn. That's okay. And if the limit An and Cn are the same thing, okay, then Bn has go to the same limit. So it's called a sandwich because Bn is in the middle, and also it's called a squeeze theorem. So when A and C is squeezed, Bn goes to the same limit. Okay, so this is the conclusion. Let's see how to use this theorem to find some other kind of limit. Let's take a look at this one. Cosine n over n. Okay, the interesting thing is cosine. Cosine, let's take a look at the graph of cosine. So start from here, okay. And it's periodic function, right? This is cosine x, okay. And let's see. Either limit for this sequence, we are going to do this way. The interesting thing is cosine x is always greater than -1, less than 1. They're right, no matter what's the x, is always in between -1 and 1. So we can create less than 1 over n, greater than -1 over n. Now let's take a look at this limit and that limit. Both goes to 0, right? So we can write down this way here. This is like an An, and here is like a Cn. They both goes to 0. So what is the limit of Bn? 0. Right? So we usually do this for cosine and sine. Whenever we have cosine sine, we like to do this way. The next one, n goes to infinity, -1 to the n over n. Okay, let's take a look at this sequence. Even this is alternating, it's positive, negative, right? But let's take a look. -1 to the power n equals -1 or 1, so it's always greater than -1, less than 1, right? And divide by n, divide by n, divide by n. Same thing, they both go to 0. So you can just write down the final conclusion. The limit is also 0. Okay, even it's alternating, but because denominator goes to infinity, no matter what's the top, the limit is still 0. Okay, here I can give you 2 exercises problem. The first one is pretty easy, n square. The second one. So in our first quiz, I'm going to give you a sequence, okay, and ask you to tell that is converges or diverges. If it's converges, find the limit. Like this one. Okay, I can give you a little bit hint. 91 to the n over 2 to the n. Actually, the both limit equals 0. That's the solution. Okay. To the n goes to infinity, right? Whenever infinity goes to 0. That's the reason. So here I use the sandwich rule. Okay, and let's see. We can stop there.